then the first part that we are going to study is the solubility rules. The solubility rules are very, very important in order to do any type of exercise for solutions or for reactions in aqueous solution. For example, the first rule says that most alkaline metal salts, the ones that contain lithium, sodium, potassium, rubidium, cesium, and also the ones that contains this cation, ammonium, sorry, then all these salts, every time you see one of these guys, you can say that the salt is soluble. All right?
Okay.
Then also when you have nitrates, acetates, perchlorates, most of these salts are soluble. But what happened with chloride, bromide, and iodide? Well, they are soluble except when the cation is silver, lead 2, or mercury 1. Okay? Then when you have one of these three cations and an ion is chloride, bromide, or iodide, these are non-soluble. For the rest of the cations, the salts are soluble. Most sulfates are soluble. Oh, but when they are not soluble, when you have barium, strontium, lead 2, calcium, and mercury 1. With these cations, sulfates are non-soluble, or you can say insoluble. All right? And are completely insoluble carbonates, phosphates, sulfides, and hydroxides. Oh, except when you have an alkaline metal as a cation. Then if you have an alkaline metal as a cation, the hydroxides are soluble. Hydroxides of barium, strontium, and calcium are slightly soluble, okay? And most oxalates are insoluble, except for those of the alkalized metal. Okay? Well, these are the rules that you have to take into account in this chapter. For example, let's try. What do you think about? You have to say if these compounds are soluble or insoluble. Sodium chloride, what do you think? Is soluble or insoluble?
Soluble.
Soluble. Oh, Tessie, good evening. It's soluble because you have sodium and you have, and remember, every time you have sodium, potassium, rubidium, they are soluble. Sorry, this is an S. Okay? What about barium sulfate? What do you think? If we go back, we can see that most sulfates are soluble, except, look, barium is not soluble when you have a sulfate, okay? Then we have to say that is insoluble. What about ammonium nitrate? Soluble or insoluble?
Soluble.
Yeah, for two reasons, for ammonia and for nitrates. Okay? What about silver bromide? Every time you have silver, what happened? And the second one is iodide, bromide, chloride. What happened with these guys? Okay, look at this. Chlorides, bromide, iodides are soluble, except for silver, lead 2, and mercury 1. Then this compound that you have here is insoluble. Okay? What about potassium carbonate? Well, you have here potassium. Every time you have potassium, sodium, you can say that it is soluble. And here you have an iodide. What happens with iodide when you have lead 2? Well, every time you have iodide, chloride, bromide, but you have lead 2, is insoluble. If you go to the rule, you will see it is insoluble. What about hydroxides? If you go to the rule, you will see that most of the hydroxides, look, hydroxides, most hydroxides are insoluble, except for alkali metals and ammonium. But in this case, what we have here, we have calcium. What it says about calcium? Oh, hydroxide of barium, strontium, and calcium are slightly soluble. When it is slightly insoluble, I prefer that you say that they are insoluble. All right, because what it means that you will have a solid always. Okay. What about phosphates? Let's go up. Phosphates, look at this. Phosphates are insoluble. Except for alkali metals. But in this case, what we have here, magnesium. Then this phosphate is insoluble. Well, this anion is acetate. And this is lithium. Lithium is from group 1. Then all the salts with lithium will be soluble. Iron 3 hydroxide. All the hydroxides are insoluble, except for sodium, potassium, rubidium, ammonium. Okay? Well, this exercise is very, very important. Try to take a picture or a screenshot from this exercise and try to do it. And the same with the solubility rules, please. You have the solubility rules in your book, but you can take a picture from here and you can use it during the activities. All right? Let's go down. Well, here you have the answer. Here you have exactly the answer for the exercise. Let's go down. The other part, well, conductivity. When the substances are have high conductivity, look, this one, this one, this one, this one. Okay, when they have a high conductivity, we say that they are strong electrolytes. Okay? Then these are strong electrolytes because they have a very high conductivity. All right? Now, let's see what happens if the conductivity is low. Low conductivity, sorry. Low conductivity, low conductivity, low conductivity. Then when we have low conductivity, we say that the compounds are weak electrolytes. This is weak electrolyte, this is a weak electrolyte, this is a weak electrolyte. And in the other hand, when they don't conduct electricity, when they they don't present conductivity, then we say that they are, in this case, we say that they are non-electrolytes. 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 Got it? Then here is a classification of the electrolytes into a strong electrolyte, weak electrolyte, and non-electrolyte. According with what? With the conductivity. Okay? Any question? No questions? No?
No.
Okay. Okay, let's go. Then, as you can see, this is a classification. You can take a picture of this. This is a classification for the substances according with the conductivity. Okay? Let's go. Now, how do we represent the strong electrolytes? When we are in front of a strong electrolyte like hydrochloric acid, sodium chloride, potassium nitrate, and magnesium sulfate, we use a single arrow and the ions, because these compounds are 100% in form of ions, completely ionized. Then when I ask you to represent a strong electrolyte, you have to use this representation. It's okay? When we are in front of a weak electrolyte, we use double arrow. Look, this is the double arrow. And then we have the compound in equilibrium. This double arrow represents equilibrium with the ions. But what happened with these substances? They have only a few ions. And mostly they are in form of molecules. What happened? Molecules don't conduct electricity. And the ions, yes, they conduct electricity. But as we have a few ions, that's why the conductivity is very, very small. Okay? And When we have a non-electrolyte, we can represent it this way. C12, H22. This is sugar. This is sugar. It is a non-electrolyte, then we use a single arrow. This is the solid. We dissolve it, and then we represent the same substance in aqueous solution, AQ, but in form of the molecules. And molecules don't conduct electricity. That's why they don't conduct electricity, because in solution they are in the molecular form. No ions. Got it? Any question about the classification of the substances according with the conductivity, and also how can we represent the these substances in solution? Any question?
So for the non-electrolytes, do we still need to put an arrow?
For strong electrolytes?
No, for the non-electrolytes.
For, yeah, only one arrow, but look, the difference here is solid, and here in AQ, in water solution, AQ solution.
Okay,
But they are in form of the molecules. Got it?
got it.
They don't conduct electricity because they are molecules. All right? Well. This is the most important part. When we have a solution in aqueous, a chemical reaction in an aqueous solution. Look, sodium chloride in aqueous solution means that it's soluble in water. Silver nitrate is soluble in water, then both are soluble. Sodium nitrate is soluble, but look at this. Silver chloride is non-soluble. Then we write as a solid. That's what we write, the S. Okay? Then in order to get the net ionic equation, we divide the substances that are in aqueous solution that are soluble, we divide them into ions. Sodium cation in aqueous solution, chloride in aqueous solution, silver in aqueous solution, nitrate in aqueous solution. Then the arrow. Sodium nitrate is also soluble. So I divide into cation and anion. But what happened with silver chloride? It's a solid. Then I cannot divide into ions because this compound is a solid. And now, what is the following step? The following step is to look at the spectators. What are the spectators? Are ions that are the same way in the reactants. Look, sodium and sodium. And then I cancel them because they are the same in the reactants than in the products. Chloride, chloride is not. Look, here is a solid, is different. Then it is not a spectator. Silver is a spectator. No, because here is in the solid. Nitrate is an spectator. Yes, then I cancel the spectators. I cancel up the spectators. And then the net ionic equation is the rest. Chloride, silver, single arrow, and the solid. And this is the net ionic equation. Or equation, sorry. Okay? Any question? No questions? Sorry? Do you understand?
Yep.
Okay, let's go to the following exercise. Let's go to the following exercise. Here we have barium chloride. Look, soluble, soluble. Oh, solid and soluble. Then I divide barium chloride. These two goes in front. Then hydrogen, the two goes in front, and sulfate. I divide into ions because they are soluble. Every time you see AQ is because they are soluble. But barium sulfate remains as a solid. I cannot divide because it is non-soluble, it's insoluble. But here, yes, the hydrogen proton, and here chloride. Well, now I have to look at the spectators. Barium is a spectator. No, because it's in the solid. Chloride is an spectator. Yes, then I cancel it in both sides. Hydrogen is an spectator. Yes, then I cancel hydrogen. Then what is the net ionic equation? Barium plus sulfate that produces barium sulfate. This is the net ionic equation. Got it? Let's do one more example. Let's do one more example. Look at this. Here we have this solution that is made of lead 2 nitrate, soluble. Potassium iodide, soluble. Then I divide in lead 2 into nitrate, into potassium, into iodide. But what happened here is a solid, remains solid. Potassium nitrate is an aqueous solution, is soluble. Then I divide into ions. And then I go to cancel out the spectators. Lead is an spectator. No, because it's in the solid. Nitrate is an spectator. Yes, then I cancel nitrate with nitrate. Potassium is an spectator. Yes, because it's the same way in both sides. Iodide is an spectator. No, because it's in the solid. Then the net ionic equation is this one. Any question? Everything fine?
Yeah.
Okay, okay. Then I can see that there are some students here. Okay, okay. Anyway, I'm going to post later the video of this meeting, and you can see again as many times as you need in order to understand it. Okay, thank you for being here. And as always, remember that we have the following week, we have another chapter. Then the other week is the spring break. And then on Sunday and Monday of the following week, we are going to have the second exam. Well, have a good night. See you.
Thank you. Good night.
Thank you. Bye.
Bye-bye.